Thank you, and thanks for coming to the session. The work I'll talk to you about today is joint with Lisa Vesterland, who's in the back, and Juan Z, who's at Concordia. So I'm going to give a quick overview in the first few slides so you get the gist of the paper, and then go into more of the details. So the standard economic model of charitable giving, as you know, is impure altruism, and that's a dual motive theory. So it has an altruism piece and a warm glow, or for the psychologists in the room, an egoism piece. Lots of work over the past 25 years has been built on this model. And here's the extent experimental design. It's a balanced budget crowd-out test, at least the extent design in economics. So you have the blue numbers, the $4 say, is how much the recipient has, and then the green numbers, how much you have. So in the first one, we have a recipient who has $4 and you have $46. It's a dictator gain. You can give some money to the recipient, and we're going to compare what you do in that situation to what if we change things around and give the recipient $6 more, but essentially take those 6 from you. So let's say you, in the first instance, give $19, but when we take $6 from you and give it to the recipient, you respond by giving $6 less yourself. You give $13. Well, from the total received by the recipient, nothing's changed. So that's the prediction of pure altruism. And that's the extent experimental design, is to run that experiment, see what actually happens. And what actually happens is people don't reduce the amount they give to the recipient dollar for dollar. They reduce it by a percentage of a dollar. So there are experiments where the recipient is another student. There's an experiments like the one Kathy Epple, Phil Grossman have done, where the dictator or the recipient is an actual charity. And you get, there are voluntary contribution mechanism experiments that do the same thing. And the blue numbers are the range of estimates of the crowd out. So if those numbers were 1, that would be the prediction of a pure altruism model. But the numbers are less than 1. So the 2 results that come out of this literature basically are that pure altruism is rejected. And then there's some sense of that the size of those numbers, the smaller they are, indicate the strength of warm glow. So there are 2 limitations in this literature. The first is that the experiments have measured crowd out around only 1 level of giving by others. And we have 2 results that tie into this limitation. The first is that the power of the experiment to reject pure altruism varies with the level of giving by others at which the test was conducted. So in the example I gave, the levels around the $4 to $10 range, the power to reject altruism will be different if we do that test at, say, the $28 to $34 range. The second result is you cannot identify the strength of warm glow and altruism preferences from that single measure of crowd out. The second limitation in the experimental literature is that the incomplete crowd out prediction was intentionally built into the pure altruism model to begin with in order to reconcile the theory with pre-existing field evidence that the theory didn't align up with. So impure altruism, this dual motive theory, has never been subjected to a test that it was not intentionally designed to pass. And so we will introduce a new experimental design, and it will give you a test that, at least in principle, impure altruism can fail. Well, the result is that it does not fail the test, and we find the crowd out decreases as giving by others increases, which is the essence of the test. However, that said, the warm glow we measure in the experiment is weak, and altruism largely explains why people give in this experiment. So here's a brief history of altruism in economics. I put up the early dates just to let the psychologists in the room know that we're not all cold-hearted. I can't say any more than that. So the pure altruism model has predictions, and here are the predictions that just do not line up with reality. The one we're going to focus on is this third one, the crowd out prediction. Pure altruism predicts crowd out is complete. But the econometric studies that have been done before the experimental work got underway found the crowd out was between 0.05 and 0.34, pretty small. Impure altruism. What does that do? It adds a second component to a second utility source for giving. That's the big G is the pure altruism, the public good, the output of the charity that people are supposed to care about. The red G is the warm glow piece. It's the private motive for giving. Why add the little g? Well, there are other sources of utility from giving, obviously. Those are listed with avoiding shame, avoiding guilt, positive self-evaluation, what the economists call warm glow, what the psychologists call egoism. And then Jim, in his paper, that said another reason to add the warm glow components, it's going to be fairly obvious that neutrality, that means the prediction of $1 complete crowd out, will be unlikely to hold with warm glow giving. And it'll generate a model that's consistent with the empirical observations that I had in the last slide. How does impure altruism do this? It does this by adding a second income effect. So the angle curve for the public good is now, depends upon W, which is your own income, your own resources, plus the giving by others. And so there are two income effects. The first one is the familiar own income effect, how giving to the public good that includes your own giving goes up. When your income goes up, that's Q1. And then the second income effect that's added by the warm glow piece is Q2. That's Q1 plus Q2 is that how much the public good goes up when giving by others go up. What is Q2? Q2 is the extra income effect that you, the donor, get when giving by others goes up, compared to the income effect that occurs when your own income goes up. So here's what you get out of this model. It's really, Jim's solution is really elegant. And go back and read this paper. It's, you appreciate it each time you reread it. The model nests all the alternatives. So at the one extreme, pure altruism is what you would get if this Q2, if the difference in the income effects is 0. Impure altruism is there's a difference in those income effects. Q2 is positive, but the sum of Q1 and Q2, and that's how much the public good goes up when giving by others goes up, is less than 1. And a pure warm glow model is at the edge of that, where if giving by others goes up by, say, $100 and you don't react at all, on that margin, you're giving because of pure warm glow. So the corresponding balanced budget crowd out predictions are listed right underneath. Note that both, again, the balanced budget test is the example I started with in the beginning. Both impure altruism and pure warm glow predict that in response to the switch I went over in the beginning, giving will fall, but not by a complete dollar. It'll be 1 plus Q2, 1 plus the difference in those income effects. So here's the point of departure for the paper we're doing. As the giving by others increases toward infinity, Q1 plus Q2, the second income effect, goes to 1, and crowd out goes to 0. That's true under fairly weak conditions on preferences. And the way it works is that the utility that's got these two pieces in it asymptotically separates. And each piece is separate from the other in the limit. And the marginal utility of the altruism piece, the public good piece, goes to 0. In the paper that we're doing today, if you add to these conditions that utility is additively separable and has positive third derivatives, then Q2, that's the difference in that income effect, is monotonically increasing, and the crowd out is monotonically decreasing. So let me introduce a Cobb-Douglas impure altruistic utility function. We're going to use it for two things. We're going to use it to illustrate some of these points. But at the end, when we get the experimental data, we're going to use it to estimate preference parameters for altruism and warm glow. So just to review the Cobb-Douglas utility function, alpha is the weight you give to altruism, and beta is the weight you give to the warm glow piece. If alpha is positive and beta is 0, it's pure altruism. If alpha is 0, beta positive, it's pure warm glow, and if they're both positive, it's impure altruism. So a demonstration of the monotonic change in Q2 as giving by others goes up. So on the vertical axes, we're plotting Q2. That's the difference in the income effect. The dashed line is the crowd out. So if you do one of these balanced budget crowd out experiments, what you would expect to see if, of course, utility is Cobb-Douglas, the altruism parameter, which didn't show up, is the 0.40, and the 0.1 is warm glow. So this is a person who's a really strong altruist compared to their warm glow piece. So let's focus on the dotted line that's going down. The horizontal axis is giving by others, and as giving by others is going up, the amount of crowd out is going down, the size of the crowd is going down. So our first point is, if you do run one of these experiments with a low level of giving by others, so you measure crowd out down here someplace, crowd out's going to be close to 1, that's the pure altruism, that's the level it would be under pure altruism, and you'll have less power to reject the model of pure altruism. And if you do the experiment down here around $30, for this preference structure, crowd out's predicted to be around 0.5, so you'll have more power to reject pure altruism there. So actually, where you conduct these dictator games, the level of giving by others affects the power with which you can reject pure altruism, if impure altruism is the correct alternative hypothesis. So that's the first result. The second result is, if you just have that one measure of crowd out, you can't identify the strength of warm glow preferences. So here's a similar plot. The red dashed line is the same that I showed you before. It's the crowd out if the person is a relatively strong altruist. And imagine we run an experiment where we've estimated crowd out around the level of giving by others of $10, and we've measured crowd out to be 0.8. The other lines show you alternative preference structures that are also consistent with that observation. The first one above the red line, the 0.32, that's the alpha, so that's the strength of altruism, and the 0.40 is the strength of the warm glow. So relatively the same. And then the dotted line is really strong warm glow, weaker altruism, and there are infinitely many combinations of alpha and beta that will fit through that one point, including a pure warm glow version where alpha is 0 and the warm glow parameter beta is 0.8. So the second limitation is that we do need a test of impure altruism. Remember, impure altruism was intentionally designed to generate the prediction of incomplete crowd out. So we're going to give you a test that was not of a comparative static prediction that was not built into the model. And that is that as we increase the level of giving by others from a low level to a high level, and we'll test whether crowd out gets smaller. The two main features of the new design are, as I just said, we're going to estimate crowd out at 2 different levels of giving by others, but we're also going to create an individualized real-world charity so that we can really control the level of giving by others, including the giving by others that's being done to the charity from outside the experiment. Here's the design details. Each participant in the experiment is going to be paired with a child between 1 and 12 years old whose house has suffered extensive fire damage. The participant can give through the experiment to the Red Cross of Southwestern Pennsylvania, which will use the donation to buy books for the child. I won't read the rest of it in the interest of time, but the books are going to be used by trauma recovery experts to build a bridge to the child to get that child to be able to talk about the trauma that they've just experienced. The Red Cross helps these families with temporary shelter, clothing, and meals, but they, prior to the experiment, had no items to give to the children by the fire. That's how we can control the giving toward this goal from out by others outside the experiment. It doesn't go on. Each participant makes 6 decisions. 1 out of the 6 is randomly selected for payoff. The payment to the participant is based on their decision plus a $5 show-up fee. Here are the 6 decisions, the 6 budgets that each participant is faced with. The highlighted budget is the example I gave in the beginning of the talk, where we, the foundation, the experimenters, are going to give $10 to buy books for the child, regardless of what the participant chooses to do. The participant has $40. They have to decide how much of that they're also going to give to buy books for the child. And from those 2 budgets, we'll be able to estimate crowd out at the low level of giving by others. And then from budgets 4 and 6, we're going to make that same $6 change, but the level of giving by others is much higher. It's in the $30 range. This is the appeal from Sandy Wraith, who was the Red Cross coordinator that we worked with. It's probably too much to read in 5 minutes, but the point is it's an empathically charged appeal. We didn't script it. It was came out of Sandy's mouth. Average giving in the experiment from 0 to $42. This demonstrates that there's lots of variation in giving, not too many people on the corners. The first result, let's focus on the number in green. That's crowd out at the low level of giving by others. It's 0.97, indistinguishable from 1. If that's the only experiment we ran and reported, we would not be able to reject pure altruism. But at the high level of giving by others, crowd out is 0.82. We can reject pure altruism. The difference between those 2, the difference in crowd out is the 0.18. That's statistically different from 0. This is consistent with impure altruism. So impure altruism passes the test that it wasn't designed, wasn't intentionally designed to pass. That's just all the results together. This is another version of the test where the changing, this is the unfunded crowd out, the Q1 plus Q2. Again, the change in crowd out is the 0.22, statistically different from 0, again, consistent with impure altruism. We next move to use the data from the experiment to estimate the Cobb-Douglas structural model of impure altruism. The altruism coefficient is estimated to be 0.594, close to 0.6. The warm glow piece is 0.021, statistically different from 0, but very small relative to the altruism piece. Next, we have 85 participants. Estimate the same 6 decisions for each participant. Estimate the structural model for each participant. So everybody gets their alpha and beta estimated and plot them on the scatter diagram. There is a lot of interesting information in this picture. First, note that there are a lot of participants on the vertical axis, which are the pure altruists. Not so many on the horizontal axis, that's the pure warm glow people. The scatter demonstrates the difference between altruism and generosity. Generosity is something like how far you are from the origin. Altruism is the angle of where your point is. So it's, even though the pure warm glow people are not altruistic, most of them are very generous. Also, what you get from the scatter is that for most people who have both an altruism and a warm glow piece, the altruism piece is the bigger of the 2 pieces. That is, most of the dots are above the 45-degree line. And then finally, what a little bit surprising to me, there are not too many people who have sort of equal shares of both pieces. You can use these the scatter diagram to and the structural estimates to estimate what share of the giving was due to warm glow. And if you use the representative alpha and beta, that's using one model to describe all the participants. That's the 0.594 for the alpha, the 0.021 for the beta. We calculate that somewhere between 4 and 9% of the giving is due to warm glow. It depends what budget you're making the calculation at. If we use the representative, it should be the heterogeneous model, not representative. So everybody's got their own alpha and beta. The share is larger, somewhere between 22 and 33%, but in both cases, the majority of the giving is not coming from the warm glow piece, it's coming from the altruism piece. Why these results are important? Well, the results are significant for experimental methods for two reasons. One, you need to identify, if you want to identify the relative strength of altruism, warm glow, you need to measure crowd out around more than one place, more than one level of giving by others. Second, it's a new test of impure altruism based on a prediction that was not intentionally designed into the model to begin with. Two substantive results. These are the first results describing heterogeneity across individuals in their dual altruism and warm glow motives to give, and it's evidence indicating the strength of altruism. In the experimental context, we established the participant motives differ from previous experimental results that have suggested warm glow is a predominant motive that people give to charity, and we've demonstrated by example that there are charitable giving environments where altruism is the predominant motive people are giving. Practical implications in the last slide are for how fundraising communication takes into consideration why might our potential donors give, what might be motivating them, and then also how donors reflect on what they're doing. Why do I give? And then thanks to these people.
Okay, so I guess we will hold the question till the end because we are a little tight on time. So our next presenter